area as of today. All the orange areas.
Now, sorry, what do you mean by, that means they've acquired leases, permission from the landowner?
No. So they basically filed a request or
To have access to those areas?
yeah, so it's an exploration license that someone's paid. I think it's $10 per block, and there's
Right.
many blocks that are covered. So this is the first step in beginning to explore.
And does that refer to uranium? No, that's just generally.
This is just general. So I'll explain that in a sec, but since March 1st, all of these yellow ones are new claims that have been filed. So that's since the lifting of the uranium ban. However, we don't know what the actual purpose of these exploration licenses are. It could be a gravel quarry, it could be sandstone quarry, it could be other critical minerals, so it could be any of those, but this is the actual area where uranium is likely located. So you can quickly gather you can suppose what the purpose of those particular licenses could be. So that's a quick overview of the map. I do want to say that this was all work of another person, Noah, who also did the maps up there. So thank you, Noah, for all of this. And we can get to more questions on these later, but I think we should go straight to...
Oh, I was going to read Brian Galt.
Oh, you
and I forgot.
Yeah, go for it.
Okay, I have a statement from Brian Gawkey, who couldn't be here tonight, but he lives here in Tatamagouche, and he is a certified health physicist from Health Canada Atlantic Region Radiation Specialist. He's retired now. But he prepared this little sheet. So just imagine that I am Brian. This is what I would sound like if I was smart. Because of uranium's solubility in water, disturbance of uranium-contaminated rock caused by exploration and mining has the potential to increase both uranium and radon levels. Radon is a radioactive gaseous element which has been shown to increase the potential for various cancers, particularly lung cancer. Airborne radon enters homes through basements and crawl spaces where it tends to concentrate. Radon can also enter via well water contaminated with uranium, contributing to elevated radon levels in the home, as well as increased cancer risk from human consumption. Homeowner mitigation for increased radon levels in both air and water is expensive and never 100%. It also requires continuing testing and maintenance. Due to the financial costs and increased health risks, the presence of elevated radon levels in air and water can negatively affect property values. These risks are exponentially increased by mining activities because they take place in the areas of highest concentration and over a very large area. In addition, mining creates huge amounts of waste rock and mill tailings. This is why most uranium mining is done in relatively arid and sparsely populated areas. One notable exception has been in the southwestern US, where mining has often been conducted in areas occupied by indigenous peoples who have experienced elevated cancer levels as a consequence. The May 27th, 2025 letter sent by Nova Scotia Department of Natural Resources, the DNR, to property owners living in areas where the government issued requests for proposals for uranium exploration raises a number of additional issues. DNR's letter states, if uranium exploration will also help people manage their health and safety in terms of well water and radon gas in homes. I cannot imagine how uranium exploration could, quote, help people manage their health and safety in terms of well water and radon gas in homes, as it can increase the risk of uranium contamination. Is the government promising to support increased well water radon testing and mitigation measures for homeowners? If so, this may detect but does not undo any damage done. Also, I presume that any support will be conditional on proving to the government's satisfaction that problems with well water or air quality are due to uranium exploration, which based on past experience would be difficult and rarely successful. If the government is concerned about helping Nova Scotians manage the health impacts of uranium, they should already be taking whatever steps are available and should restore the ban on uranium exploration in the province. Regarding the requirement of companies to remediate any disturbance they make to your land, that means restoring it to the state it was in before exploration started. The best these companies can do is remove waste products and fill in the holes left behind. There is no way to remediate the damage done by uranium contamination released into groundwater by exploration or mining activities. Finally, DNR's letter states, quote, "We are hopeful that Nova Scotians will consider the economic and health benefits of exploration as they consider the request of a company." There are no possible health benefits in uranium exploration, only risks. Regarding economic benefits, we need to ask who benefits from uranium exploration and mining, and how do these benefits compare to the risk to existing industries such as tourism, fishing, and agriculture, which collectively are worth billions of dollars to our economy. What about the effect on property values and pressure on our already overtaxed healthcare system due to increased cancer rates and other health impacts associated with living near or working in uranium mines?
Thank you, Linda. And now it's my great pleasure to introduce our speaker for tonight, Dr. Elizabeth Kosters. Dr. Kosters is a geologist, originally from the Netherlands, where she completed her studies. She did her PhD in the US, where she worked for nearly a decade for departments of natural resources, or state geological surveys, as they're called down south. She is a retired professor, independent researcher, moving to Nova Scotia in 2002. She was affiliated with Acadia and Dalhousie universities before her retirement 10 years ago. Please join me in welcoming Dr. Kosters.
Well, after that very eloquent letter, I have nothing to add. So I'll try. But yeah, that was extremely well put and should be printed all over the province in big bold letters. So I'm very glad to be here. Thank you, and I hope I can answer some questions. Some of you may have also been at the River John meeting, which was apparently yesterday or the day before.
Thursday.
Oh, it's Thursday. And there was another geologist, Brad Brennan, who was apparently at that meeting. I've been talking a lot with Brad in these last few weeks. I didn't know him before all this happened. And he actually has experience in uranium exploration in Labrador. And I often explain to people that being a geologist is like being a doctor. When you have a heart problem, you don't go to a dermatologist, and vice versa. And for us, the the planet is one body, and of course, among us there are many specializations. I am a sedimentologist, I deal with sediments. Brad is a minerals geologist, and that complements each other very well. So it's been very helpful to be able to talk to him, because this kind of stuff is actually not my specialty. But I'll do my best. I wanted to give a land acknowledgement, and I'm glad it was given. So, a few facts about uranium. This was supposed to be timed. What happened? It didn't do that. Uranium is the heaviest element on Earth. Every element consists of a core with protons, which have a positive charge, and neutrons, which have no charge, and it's surrounded by electrons, which have a negative charge. In stable elements, the balance is, the charges are balanced. Uranium is unstable. It has way more neutrons and protons than electrons. The charge is not balanced. And so what it does is it tries to become stable. And it does that by ejecting protons or neutrons, and this is what is radioactivity. That is the radiation of an element. And it becomes something else in doing so. I promise I won't trip. The complete process from uranium to lead, so this went onto a map, so yeah, a few things changed, but that's okay. We'll work my way around it. The complete change from uranium to lead, which is the final step in that process, and lead is stable, takes 4.5 billion years. And that is what we call a half-life. So the half-life of uranium is 4.5 billion years. That means that in 4.5 billion years, half of its original material has decayed to lead. By complete accident, our planet is 4.5 billion years old. So that means that all the uranium that was there originally 4.5 billion years ago, half of it has decayed to lead, the other half is still there. You need to live a very long time. We won't live long enough for all the uranium to be decayed. It will always be with us. So radioactive material, uranium in the earth crust will always be with us. So the thing is to know it, to understand it, so that you can mitigate your life around it, as was just mentioned with water and radon. So during that decay process, it becomes many different things, and for a while it exists as radon, which we just talked about, a radioactive gas, and both of them are abundant in our bedrock and in our basements and form a public health risk. So how do we understand the geology of Nova Scotia? And I didn't have any more extras, but if you are interested, there's an organization called the Atlantic Geoscience Society. They're online, and you can order the geologic journey map from them for $10. Most tourist outfits have it as well, and then you can. It's done for the lay public, and it's a very good product. So how do we get this uranium here in our subsurface near us? So this is a cartoon. This is not us. So it's a very common element in our earth crust, and it's risky. It's more common than gold, to talk about another one that our government loves to talk about. It wells up from below in the continental crust. It takes a very long time. And this upwelling is not a volcano. It likes to attach itself. I had this beautiful pointer that was made for me. Oh, here we go. It likes to attach itself to silicate minerals. Granite is 100% silicate minerals. I was talking to people in Lake Paul yesterday, they live on top of granite. Every other rock except gypsum and limestone and salt is silicate. So uranium likes to attach itself to basically every mineral around us. And it can become mobile. That's one of its elements. So this is, as an example, the South Mountain granite body. It pushes up through the Earth's crust. It did that about 400, and parts of that granite body are also here in the Cobequid Hills between Truro and here. It's so nice to drive, which I did this afternoon, to drive from Truro. You go up, over through this uplift, and you come down in here. That's hard rock back there, and there is a certain amount of granite in that. So the granite body pushes up. The land, of course, instantly begins to erode, and the sediment coming down gets deposited in the surrounding areas. And the uranium that is originally in the granite moves with the eroded and the redeposited sediment, and it ends up in the rocks surrounding the granite, the deposits that are formed from the eroded granite body. That takes also tens to hundreds of millions of years. And so what you end up is this. You have exposed granite bedrock and other rock around it. This is a cartoon. This is a cartoon. So if we go to our area here, we're here in Tatamagouche. Here's the Cobequid Highlands. All this red stuff, don't get confused. Don't think this is difficult. This is not difficult. All this red stuff, all these beautiful bright colors are granites, igneous rocks, rocks that come from the interior of the earth. And they are hard, and that's why we have these lovely hills. They weathered down, and the sediments became deposited on all sides. And here we have this big blob of brown colored material, which is all the carboniferous sediments in this basin, which contain all the mobilized uranium from the original igneous rocks. So that's sort of the blob of, that's my PowerPoint artism. That's sort of the blob of igneous rock that was pushed up and eroded to either sides. And these rocks are all much younger than this. And that's where the uranium ended up. So this is the very simplest way of putting the geology. And so the uranium, as it is moved, it mobilizes, and it decays to radon. And we've known in Nova Scotia for a very long time that those are health risks, and that we shouldn't expose population to more risk than we need to. So the uranium in the granite bodies, as you've just seen, that's a blob that comes up. It sort of is distributed in there. It's not quite random, but it's more random than the way it's distributed in the sediments that were deposited on either side of that blob as that blob came up and eroded. So we'll look at a picture. In the sedimentary rocks, the uranium moves through the sandstone and alters as it goes, and this is what's in industry called a roll front deposit. I'll have a picture. In the granite, it is more randomly distributed. In some parts, it's more concentrated than in other. This is what the exploration research is doing, is trying to find out. And so then, at some point, they'll find a place where it's most concentrated, and it will mostly be open pit mining there. The roll front deposits will, which is what this would here in the Tatamagouche in the sandstone will be mined by what's called solution mining. And this is what a roll front looks like. So if you think that the Cobequid Highlands are here, then this is your sandstone. This is a cartoon. This is not based on this area, but this is how all roll front deposits in the world more or less look like. So it's a cartoon. This is from a company. So you have impermeable beds and sandstones. Anybody who lives here, of course, has been to the coast. That's where these sandstones crop out, and we all know they're not homogeneous. We all know that they look like harder and softer, and that's because of the processes in which they were originally deposited. So the sandstone bodies are not homogeneous. And so there are clay layers which are less permeable, and sand layers which are more permeable. And the uranium moves preferably with the more sandy layers, and is confined between clay layers. This could be any scale. And as the material moves through this sediment, this becomes oxidized, and that becomes unoxidized, and this red material is where the uranium is concentrated. This goes very slow, of course. Also takes millions of years. So what they're trying to do is find this, which is where the highest concentration of uranium is located. That's what the exploration is all about. Now, how do you produce uranium by solution mining from such a roll-front deposit, which is what this area would be, not open pit, but this roll-front solution mining. So what they do is, here's your roll-front, and so what they do is they have monitor wells. This has no scale, but we'll have a picture of what it might look like. And then we have water that's flushed through here with all kinds of chemicals in it, of course, because you have to release that uranium from the rock. And flush it up under pressure to a plant where it is distilled, and that's not the right word, I'm sure. And then the wastewater goes back down. Oh, we've got it contained, it's back down there. There's multiple ways in which this can go wrong. Needless to say, oops. No. So this is more or less what a plant like that looks like, and this again is a cartoon, but it is a massive industrial complex once you've decided where that's going to take place. And I'm not even sure anybody can claim that that is completely safe. Now the notion is, of course, that we should be energy independent, and we should get rid of fossil fuels. We sure do. But there's no reason to do it here. This is Saskatchewan, northeastern Saskatchewan, and within that oval, which is about 200 by 160 kilometers, are, I think, 6 or 7 uranium mines. This is an uninhabited area except for the indigenous community of Volso Lake, who cannot hunt or fish there because of the radiation from the waste. And that's true for most of that area. And the same is true for Elliott Lake in southern Ontario, which was a uranium mine back in the 70s. But the point of this is nobody lives here.
You just told us people live.
Yes, there's this one community of I think it's 200 people. There are otherwise no people. This is the highest grade uranium in the world, and it is relatively easy to get at. They're also exploring just across the border in Alberta. And the woman who's a prof at St. Mary's, Erin Adloa, who did her PhD on those. Now, if you project that same area in southern Nova Scotia, you have this same, we are exactly that oval, and there's 500,000 people in there. And that's not counting Tatamagouche yet, but I prepared this for the Lake Paul meeting. So that entire Saskatchewan mine area, and this area is also a lot wetter than Saskatchewan, which means that mobilization of uranium is more likely than in an area like Saskatchewan. So why is this happening? It makes no sense. Even if you are in, I mean, we're all in favor of decarbonization. We're all in favor of other forms of power production. So why would we not be in favor of this? Clearly, the health and environmental risks are too big, and we have this massive mine in Saskatchewan. But this is what's happening right now. The stock market price is high. It's the highest level, well, in 3 months. This is a direct quote from this commodity website. The possibility of political support for the nuclear sector is going up. The person whose name should not be mentioned is in favor of increasing nuclear power production. because of Bitcoin and AI. And so there's a growing demand for uranium in the US, but the US is energy insecure when it comes to uranium. They don't have all of it themselves. They have a significant amount, but not what's going to be needed. And they're throwing import tariffs on all these other countries, especially on Kazakhstan. Kazakhstan is the largest uranium reserve in the world. It ships yellow cake to the US, but it's facing a 27% tariff. And so this is what is, I'll send you that slide, Joan. This is what...
You, I won't.
So this is the insecurity in the market. This means that there is a perceived scarceness of uranium, and of course this is what the whole commodity market thrives on. They don't make any money mining, they make money in the stock market. In my view, this is what's happening, what's behind all this. And so I want to leave you with one quote by somebody who I very much admired, Edward Wilson, who was a biologist. If there had been a Nobel Prize for biology, he would have had it. And he conceived of this concept called half-Earth. I mean, we're in a biodiversity collapse. We all know that. And he said, we cannot deny that there are 6 billion people who need a lot of stuff. So, okay, let's just accept that, and let's set aside half of the Earth so that we can actually survive, because we need the Earth to be functional. There are no insects, therefore there are, the swifts population are declining, etc., etc. So whatever your position is on uranium mining, in general, there is enough uranium of the highest quality in an almost uninhabited part of Saskatchewan. Canada's energy security is not at risk by any stretch of the imagination. But we're also in a biodiversity crisis. Anyways, nobody has cleaned the windshield in years. The bugs are gone. We have over-exhausted the natural environment that we depend on. And we need resources for 6 billion people. We're expected to stabilize at about 6 billion. So let's just leave it at that. We must protect our habitat in our own self-interest. And so we must be much more selective. In the past, we've just mined and extracted resources in a shotgun approach. It's there, we'll dig it up. It's there, we'll dig it up. And only the environmental movement has somewhat been able to channel that a little bit. But the general approach is still a shotgun approach. So we must strive towards protecting, towards not extracting what we really don't need. We don't need this at all. And to protect half of the Earth in our own interest. Mining uranium in Nova Scotia will not improve understanding of public health issues. We know exactly what the risks are. We know exactly what to do. That's why the ban was installed. And it won't provide jobs, by the way, because this is all done robotically with people as far away as possible. And, it's not going to have any long-lasting jobs. As none of the resource extraction that Nova Scotia has done over the past 2 centuries has provided. It's always been big promises. And Joan is here, and she has written extensively on the gold mining. It has given us nothing, except big share value of profits for shareholders. So I would like to leave it at that. Thank you. It went a little off the rails because I lost 2 slides in the transfer from Bill Gates to Apple, but that's okay. All right, any questions? Oh no, I'm giving it back to the moderators for questions.